Theorem 5. If parallel lines are intersected by a transversal, then the corresponding angles are equal. Now, before we go any further, perhaps it is important to understand some of the terminology that is used in this theorem. I will start first by breaking down the word transversal. Now, a transversal is defined as a line that cuts other lines. Now, this means that if I were to have a line that goes like this, and I have another line that goes like that. If I draw another line that comes in between these two lines and cuts these two lines, it intersects them here and here, we then call this line a transversal. So this line becomes a transversal. Is called a transversal. That's the first thing we need to understand here to break down this theorem. So in this theorem, we're saying that we are having parallel lines, we are having parallel lines that are intersected by a transversal. So here we have line 1, which is parallel to line 2. So that means these two lines will never cut each other. They maintain the same distance here between them. Now, you should realize that when these two lines are just parallel like that, let me draw them this side to make my point. If I have line 1 and I have line 2 like that, these two lines are just lines that are parallel to each other, meaning they'll never cut each other. And there's no any angle between them. The moment I draw a transversal like this, I then create different angles. And that's what's happening here. When we draw a transversal between these two lines, we then form a number of angles here because we have vertices. Remember, I'll have a vertex here, a vertex there, a vertex here, and a vertex here, therefore making those angles as a result. Now, these different angles have names to them. So here we are interested in corresponding angles. Corresponding angles will be angles that are on the same side of the transversal and the parallel line. What I mean by that is that if we look at the transversal here, this angle A1, it is to the right of the transversal. And if we look at this line L, this angle here is below that line. Now, when we come to point B here, the same thing is true. If I draw a transversal here, this angle, it is to the right of the transversal. And when we look at this parallel line, it is below the parallel line. It's like these two angles are on the same positions on these two different points. We then call them corresponding angles. They correspond with each other. Now, when you have such a configuration where there's parallel lines, a transversal, and creating the corresponding angles, we then conclude to say those corresponding angles must be equal, must be exactly the same. So when here we are saying the short version of writing this theorem then becomes the fact that we have corresponding angles that are caused by parallel lines, right? So we have corresponding, so that's a short way of writing this theorem to say we have corresponding angles that are caused by parallel lines, right? So when we have such corresponding angles that are caused by parallel lines, we can then conclude to say those corresponding angles must be exactly the same. Now, a lot of people memorize this very theorem by using the fact that we see a letter F here. If you look at this diagram, we have a letter F here. It gives us a letter F here. So every time you see such a letter F, you know that you have corresponding angles and you can conclude that they are the same. It is also important to notice that this very letter F can look at any direction. It can be such that it is viewed from different directions. What I mean is that we can see the letter F appearing as if it's a T here. So that means this angle and this angle will still be corresponding, because it is in the same position of the transversal and the parallel line. So that means to the right here we see this angle, and above the transversal we see this angle. To the right here and above the transversal we see that angle. So these two angles are corresponding and therefore should be equal. And the same is true this side. We can see the same thing here. This one and this one are corresponding and therefore they're equal. Also this one and this one are corresponding and therefore they're equal. We only used A1 and B1 in this situation just to simplify this theorem, but you must be able to see it from all the directions. Now, if we were to employ this in a problem solving, we would actually write this as a statement to say line 1 and line 2 are actually parallel. The reason is what we are given, is what we start with. We can see here that what we start with is that those lines are parallel. And therefore, it means the corresponding angles, which is A1 and B1, must be the same. And the reason would be that we're using a theorem that says when we have corresponding angles that are caused by parallel lines, those angles are the same, which basically is this theorem, theorem 5.